Greetings everyone. Today we will be discussing about the substation equipment, that is the surge arrestor or lightning arrestor. A surge arrestor is a device which is used to protect the electrical equipment from the overvoltage transients that are caused due to the lightning or internal switching events. To protect the valuable equipments from the transients occurring attached to the conductor, a surge arrestor is connected to the conductor before just entering into the equipment. That may be a transformer or other high voltage equipments. First of all, we should know what are the causes of over voltages in a system. That may be atmospheric, that may be the due to the switching surges, or maybe due to electrostatic induction or back flashovers. The lightning strikes can be direct or indirect. Similarly, switching surges due to the circuit breaker operation and load rejections that causes the over voltages, which can adversely affect the substation equipments. So basic principle is for the lightning arrestor, it stays non-conducting during normal voltage, that is the standard operating voltage, may it be 33 kV, 132 kV, 220 or 400 kV, and during the surge the voltage that exceeds leads to the breakdown of the metal oxide varistors inside the LA, and it starts conducting, and which leads to the diversion of the surge to earth, and again after the surge is over the LA returns into its normal position. So these are the main components. There are spark grab, nonlinear resistor, grading ring, the overall housing, and the earth terminal. Here you can see the picture of surge arrestor, the high voltage terminal, the grading ring, the insulating feet on the left hand side. In the middle, there is a surge counter which is connected in between the surge terminal and earth, and which reads the number of surges it has been encountered, and a milliampere meter is there. And on the right hand side you can see the picture where it shows the cross sectional view, professional housing, holding plate, supporting rod, MO register, cement joint, sealing ring, all the uh, arrow marks that shows with venting outlet, pressure relief diaphragm, compression spring, and the functions of each and every individual element. So what is the location in substation? As I said, it is there at the entrance of the line, for which the equipment needs to be protected at the incoming and the outgoing. Similarly, near the transformer bushings, line terminations, and inside SF6 enclosure for GIS substation, that is the gas insulated substations. And the guidelines is we should have the shortest path from LA to the ground, low resistance earthing, lead length should be less than 3 meter, and equipotential bonding of nearby structures. uh, that is the summary what I have discussed, that using the surge arrestor is to limit the voltage across the terminals of the equipment to be protected, and the main element inside the LA is the varistor, and the metal oxide varistors that contain zinc oxide and bismuth oxide is used for high voltage LA. And sometimes it also happen that the very protective element surge arrestor itself has been failed. That may be due to mechanical temporary over voltages, the cracking, puncturing, and flashover, and maybe due to aging. or pollution or moisture penetration. So these are the causes which may lead to the failure of the metal oxide surge arresters. We need to again monitor the status of the surge arrestor by following these four methods: through visual inspection, through counters, through thermovision scanning camera, and doing the LCM, that is the leakage current measurement, in between. So, as we know, all electrical equipments inside electrical system or substation need to be protected from voltage surges, and the rating of the arrestor based on the substation rating, the class of arrestor, and the location of arrestor play a very important role for the protection of the devices. And it is very much essential equipment inside a transmission or a distribution substation. Thank you everyone for the patient hearing.